Hey everyone. So in this video, I'm going to continue our conversation about electoral polls and predictions. And remember from last video, our goal here is to use this data set of 1,200 polls that were conducted over time and kind of aggregate them to get an idea of the change in support for Biden versus Trump over time as we get closer to the election, kind of similar to what has been done in previous elections to kind of predict the outcome of the election, right? So obviously the challenge here is to take all these different polls and then kind of compute a smooth trend over time. So how can we achieve this? Ultimately, what we want to do is we want to compute a moving average. So the average of the polling results within, for example, a 1 week period, right? So for example, on October 10th, we will take all the polls conducted within the past week to compute the polling average on that specific day. And we want to do that for every day, going back 300 days before the election up to now, 20 something days before the election, right? Of course, if you kind of think about how this procedure works, if we kind of change this window size from a week to maybe just 3 days, or increase it to 2 weeks, that will ultimately kind of lead to more or less smoothing as we look at this time trend, right? As we increase the number of days that we take into account when computing these polling averages, the line will become more smooth over time. We will only see more gradual shifts over time. If this window is smaller, we will see more variation between polls or between smaller time frames, of course. So when it comes to kind of the coding strategy, we want to kind of go through each day, and for each day we want to subset the relevant polls and compute the respective average for only the relevant polls that are within that window, right? In order to kind of see what the kind of period is that we want to go through, we can look at the range of the days to election variable. If we look at that range, remember from the last video, this is the range that the days to election variable we created using or by subtracting the day of the election, November 3rd, and the specific polling end date. Okay, and we see, if we look at that range, we see that I downloaded the data yesterday, and so we see that the days to election in the polls in the data set that we have here ranges between 25 days up to the election to all the way back to 307 days prior to the election, right? So we want to go through each and every day in that time frame and then compute the polling average for that window, okay? So how do we do that? Of course, we don't want to kind of compute this manually for each individual day, because then we would have to write 300 lines of code. But we want to do that by creating what is called a loop. And a loop is a very, very fundamental concept in programming that allows you to repeat a certain computation or operation multiple times, each keeping track of the number of iterations while you go through those steps, right? So the basic structure is of a loop in R is that it always starts with this for expression, and then we have this this counter, which usually by kind of customary we call I, but theoretically it could have any other name. In a certain set of numbers. So for example, in the numbers from 1 to 10, or in our case it'll be 25 through 300 or something like that. And then we open the loop with these curly brackets, and then there are a couple of expressions which could be functions, computations, creating new objects. that are then repeated for each iteration, where I is the counter that keeps track of which iteration we're ultimately in, right? So the elements, as I said, the elements of this loop are first this counter, which we usually call I, but it could be another name. We have x, which is usually a vector containing a set of ordered values that the counter takes, right? So with each iteration, this counter will take the next value that was kind of part of the x vector, right? The expressions are a set of commands that will be evaluated repeatedly for each iteration. And as I said, the curly braces define the beginning and the end of the loop. In this case, one thing that I should say is that indentation is important to make this this code readable, and I'll show in a second an example where we kind of keep track of where we are in a loop, because ultimately you can have nested loops and additional statements, and so one kind of one rule that you should follow is that whenever you're kind of in one level of a loop, they should all be kind of indented further, so that it's kind of easy to see the structure of the program. Okay, and we'll go through examples, and you'll see what I mean. In general, when it comes to kind of coding advice and how to kind of set up these loops, the easiest way to go about it is to code first without the loop, by setting this counter to a specific value. So for example, setting I equal to 1, and then kind of go through all the expressions and set up all your commands with one specific, for one specific iteration, so to speak, and then add the loop structure on top of that. So here's a quick kind of illustrative example of what the loop would look like. So for example, we have a vector of values 2, 4, and 6 that we created. We can easily extract the number of elements in values using the length command that you've seen before, and we'll just save this in the object n. Then we can, that's another important thing in loops. The first thing we want to do before we start the loop is we want to create an empty vector that stores the results, right? So before we start writing the loop, we kind of want to create a container that ultimately later on, where we will save all the results for each iteration in the loop, right? And so here we're creating a vector of NA, so missing values, that is of length n, right? So it has the same length as the number of iterations, as the number of values in our values vector, because ultimately we'll save something in there for each iteration that we go through, right? And now we start the loop again with this counter I that now takes values from 1 through n in that specific order, right? So here we will go, and n of course is 3 because it's the length of values, right? So we have our counter I, we start a for loop. Our counter I will now in each iteration take a value 1, 2, and up to 3. And then for each iteration where 1 is either equal to 1, to 2, or to 3, it will execute this code that we see here, which is we compute values I, so that's the ith element of the values vector. So when I is equal to 1, this will be 2. When I is equal to 2, this will be 4. When I is equal to 3, this will be 6. It will take this specific value and multiply it by 2. Okay, so it's basically in each iteration of the loop selecting one specific element in the values vector and then multiplies it by 2 and then saves it in the results vector, right? So ultimately, if we run this loop and then look at the results vector that we created previously, we see now the elements here are not missing anymore, but instead we have 4, 8, and 12. Why 4, 8, and 12? That's 2 times 2, 4 times 2, and 6 times 2, just as we kind of declared here in our command within the loop. right? So we're going through each iteration, and then with I kind of taking each value for this respective iteration, we're executing a certain just one line of code here, okay? In many cases, when you're working with loops, it can be helpful to print out an iteration number for debugging, because sometimes your loop, you go through a lot of lines of code or a lot of iterations, and then your code breaks at some point. And if you don't add additional kind of code in your loop, you don't know exactly where it went wrong and where things broke down, right? So here we have a separate loop where we have values that are 1, -1, and 2. And again, we create a results vector that is missing with 3 elements of NAs, a vector of length 3. And then we have, again, a loop that goes where the counter goes from 1 to 2 to 3. And then what we want to compute is, or what we want to save in results I is, instead of multiplying by 2, we want to take the values of I and take the log of that. All right, so that's the natural logarithm of those values, right? And of course, if we compute this with -1, the logarithm of a negative value is not defined, and so that will create an error, right? But if we just ran this, we would just get an error, and we wouldn't quite know where things went wrong. But if we include this additional line of code, cat iteration, I, n for new line, that means for each iteration, R will kind of print out a little message saying this is iteration 1, iteration 2, and iteration 3, right? So if we run this, we'll see that the output is iteration 1, iteration 2, iteration 3, and we see that in iteration 2, we see this warning that a missing value was produced, because the log of we can't take the log of a negative number. But this directly shows us that this warning was produced in iteration 2, right? So this can be helpful for debugging, okay? Now we want to do the same. Now we want to create a loop that helps us compute polling averages over time, right? And so we will use the same structure, but with the polling data that I presented previously, right? So how do we compute the weekly polling averages? Well, first, we have to set the days as the days that we want to take into account in order to compute these averages. And these are now ranging from 300 to 25. So counting from 300 down to 25. And the window size that I discussed earlier is now set to 7. Okay, so we will look at weekly averages of polls. Okay, and then we are going to create 2 vectors that will store results, one for the support for Biden, and then separately the support for Trump. And we can kind of write this in a chain of assignment operations. Both Biden.prep and Trump.prep is now a vector of missing values with the length of the number of day, or with the length of the days vector, which is just 300 to 25, so that'll be 275. Okay, so it's 275 individual data points or days where we want to compute the 7-week polling average. Okay. Our loop then starts with our for command. We have our counter I, and this counter I now ranges from 1 in the first iteration to 275 for the length of our days vector that we defined up here. And then these curly brackets, of course, open that loop. Okay. So as we said, the strategy is first we want to subset the polls that we have, polls 2020, to only the polls that are within that window, right? So we create a new object called week.data, and we subset our original polls 2020 according to the following conditions. First, the days to election, which are that's the variable that is in polls 2020 that we generated previously, has to be smaller than days so the specific days 300 up to 25 of that iteration plus our window, which is 7. So it has to be smaller than this number, and at the same time larger or equal than days I, right? So what does this do? We go through our days from 300 to 25, and for each day 300, 299, and so on, we select all the polls that were conducted in this window 300 to plus 7 days. Let me see. Yeah, so that were conducted basically up to 7 days after that specific day. Okay, so that's now selecting a window of 7 days for each individual polling day. Okay. Yeah, I think the way I set up the window here, it actually basically starts with 300, and then it has to be smaller than 300. Yeah, so if we're in iteration 300, it has to be basically the day of the poll has to be smaller than 300 plus 7, so 307, and larger or equal than 300. So we're always going 1 week back, right? So this is the way we kind of set it up earlier. On day 300, we want to have all the polls that were conducted on day 300 and 7 days back, basically. And then we save our results Biden.prediction I. So that's in our vector of NAs for that specific iteration. We then compute the average of our Biden support for all those polls in that subset, week.data, and for Trump accordingly we do the same, right? Then after we ran through that loop, we can plot on the x-axis, we can plot the days to the election. On the y-axis, we can plot Biden.pred as a line graph with some additional options for plotting. And then we can add lines for the Trump support, right? And now this is the resulting plot, and this looks already much nicer than the previous plots that we had. We see now average support for Biden versus Trump, and we see quite some fluctuation over time and a decent margin for Biden leading as we get closer to the election, right? There was only one time about 250 days to the election where there was some a short period where the polling average, the 7-day polling average, appeared to be higher for Trump than for Biden. Other than that, quite substantial or consistent lead for Biden. Of course, we can now change the polling window, and as you can see here, all I'm doing is there's a little this should be 300 to 300 to 25. There's a little problem here, but the code will work regardless. It'll just go through a lot of iterations where there are no polling predictions. But the important part here is that the window size here is changed to 3. And so if we kind of look at the result for that, of course we see much more variation over time. The 3-day polling average, of course, fluctuates much more between days, right? So what we see here is much more fluctuation, much higher amplitude, and of course also some points where the 3-day where there were no polls, especially if we go further back, there were some periods where there were no polls within 3 days, and so we see kind of little gaps in our graph, right? So obviously this would not be the ideal way. If we think that the 1 week polling average is a little bit too much, even shows a little bit too much variation over time, and we want a more kind of smoother line, we could also look at a 2 week polling average if we want to kind of focus on, really not only just differences because of, different polls and kind of random variation, but we really want to look at systematic shifts, long-term shifts. We can also compute a 2 week polling average, and again, this is just changing the window size here. Never mind the days. This is a larger selection, but again, for the results, it doesn't really matter because we still compute the polling averages for the range, day range that we care about. We set the window size to 14. And then, of course, we get a much smoother line with polling averages, 2 week polling averages, okay? We can add some additional information, and I encourage you to kind of check out what each of these individual commands do to kind of make this plot even more informative. We can add some candidate names using the text command. We can add additional kind of vertical lines to indicate events that might be interesting, and in order to examine whether they shifted support for one candidate or another. Specifically, I'm adding here AB line V creates a vertical line where the X or the line kind of the position of this vertical line is given by now the difference, of course, always between election day and the day of the party conventions first and the day of the debates. And then we also added some labels for debates and party conventions, right? And so the result of this is actually quite a nice plot overall. We see the 2 week polling average over time for Trump and Biden. We see the party conventions first, the Democratic conventions, which seem to increase support for Biden. You see how this went up over time. The support for Trump around the Republican convention increased only to a comparatively marginal extent. And then we see around the debates, specifically, at least according to these results, that support for Biden went up even further, and Trump further decreased. Okay, so if you, of course, this is just the polling average, and we're kind of missing a lot of important pieces that we're going to talk about going forward. And also, if you look at the actual prediction of the economist, there's a lot more to it than just computing simple polling averages. You can take into account differential sample sizes of these individual polls and things like that. And so this is just the first look, but still it's kind of interesting to kind of look at the how the support kind of developed over time. What else the last thing I want to say, of course, is that ultimately when it comes to predicting the US presidential election, it's, as we have seen in the past, it is not only about the electoral or the popular vote across the United States, but ultimately what it is about is predicting success in the Electoral College, and that's what we're going to talk about in the next video. Other than that, last thing to say, please get out to vote, get registered if you haven't done so already, and make sure that your vote is counted. And in the next video, I'm going to talk about predicting the Electoral College victory.